Hi, I'm going to do this real quick lecture on annuities. So what's an annuity? It's something like when you have to give somebody a regular payment over the course of say 10 years, a fixed term. Question is, how much will you be getting back at the end of the fixed term? So this is one of the examples of annuity, and it's widely used in insurance, in fixed income. For example, when there's a deferred coupon payment, and so on. The two formulas that we'll be using are the future value that we spoke about widely in the previous lecture. Formula is given here. Future value is equal to the present value multiplied by 1 plus R, which is the interest expressed in annual terms, divided by M. M is the number of compounding periods, and the whole thing into the power of number of years multiplied by number of compounding periods. And the second formula that we'll be using will be the geometric series progression. So in this example, there's I've used x as the variable. So 1 plus x to the power of 2 plus x to the power of 3, and so on. And last term being x to the power of n minus 1. So you can see there's a total of n terms here because the first term is 1 is equivalent to x to the power of 0. So this whole expression can be reduced to 1 minus x to the power of n, and this whole term divided by 1 minus x. Okay, so I'll be using these two formulas today. Let's look at this example whereby somebody tells you, okay, you give me $100 every half a year for 2 years, and I'll pay you 10% at the end of 2 years, 10% per annum. Okay, so when it says 10% annum, straight away you know that for every half year, it's only going to pay you 5%. So let's write down here. Sorry. So it's 5% every half year. So what you want to do is you're going to work out how much will you be getting back at the end of 2 years. So you'll be giving him $100 at 6 months, $100 at the first year, $100 at 1.5 years, and $100 at the second year. So how much is all this cash flow worth at the end of the second year? So you can do it the hard way by finding the future value of each of these amount. Let me do it the hard way just to show you. Okay. So this value when you work back to t equals to 2 we'll be using this formula. Okay, so it's $100 into 1 plus 5% because it's 10 over 2 to the power of, okay, so instead of using this t times m, which will becomes 4, because this formula is meant to be a future value of a cash flow as a t equals 0. But now we are looking at t is equal to 0.5. And how many periods are there? We have 1, 2, 3 periods. Okay, so we are going to do a future value of 3 periods into the future. So this will be 3. Okay, let's move on to the second cash flow. It's cash flow at time period 1. Okay, so this will be $100 into 1 plus 5% to the power of 2. Okay, and the third one, t is equal to 1.5. This will be $100 into 1 plus 5%. And how many periods are there? 1 period. Okay, and lastly is $100 here. Okay, so that's it. It's basically just sum of these 4 values, and you get the future value, the amount that you expect to receive at the end of year 2. Okay, let me write down the summation of these 4 values, starting from the last value. Okay, so it's 100. Let me bring out this $100 so it's simplify the whole formula. Okay, 100, 1 plus, what's this? You bring out $100, it will be 1 plus 5% to the power of 1 plus this term 1 plus 5% to the power of 2, and then finally the last term plus 1 plus 5% to the power of 3. Okay, so if you compare this whole expression and the expression that we have here, it becomes very similar. Okay, so this x, right, x will be our 1 plus 5% here. Okay, and what's n? N here will be 1, 2, 3, 4. Okay, because there are 4 expressions here. 1, 2, 3, 4. Okay, so using this formula, we can easily simplify it into 1 minus x is 1.5, 1 plus 5% to the power of n to the power of 4. Okay, divide by 1 minus 1 plus 5%. Okay, so just simply press the calculator and get the amount that you expect at the end of 2 years. Okay, so this is quite simple, and let me simplify this formula into a expression. Okay, so you can easily write the future value of a annuity as such: 1 minus, this expression is simply 1 plus r, okay, to the power of n, number of periods, divide by 1 minus 1 plus r. Okay, so this r you have to be very careful, and this is the interest rate for a period and not the annual terms as we define when we talk about future value. Okay, so just have to be very careful when you do work out the expression, and this can be simplified into 1 plus r to the power of n minus 1 over, so instead of minus r we move the minus to the numerator, over r. So this is a common expression that we use when we talk about future value of an annuity. Of course, you have to multiply by the principal, the periodic cash flow. So this will be multiplied by a p. Which is $100 in this example. Okay. So sometimes there are variation to such cash flows. For example, the first cash flow may not start at t is equal to 0.5. It may start at t is equal to 0. Or in another example, there may not be a cash flow at the end of the whole period. So it's very simple. You just basically using the same formula, you adjust for the value as at t equals 0 or the value as at t equals 2. So for example, in the first example, where I say that there's a first cash flow as at t equals 0, so just simply add the future value of the cash flow as at t equals 0. Simply $100 times 1 plus 5% to the power of 4. So this is an example where there's a cash flow as at the first period. Okay. So alternatively, another example, somebody may say that there won't be any cash flow at the end of the last period. So again, you just using the same formula and simply multiply $100. Okay, so it's easily worked out using this formula alone. And yeah, so you may be asked, what is the present value of this whole cash flow? Again, you can easily use this formula by discounting the whole future value to the present value. Okay, so quickly using this formula again, present value will be 1 plus r to the power of n minus 1 over r I'll ignore this P for now. So how to discount this to the present value? Simply divide by this whole expression, divide by 1 plus R to the power of n. Okay, so again, let's simplify this one. This term go into the numerator, so this will become 1 minus 1 plus R to the power of minus n over R. Okay, so this is the present value of an annuity. Okay, that's all I have for now. Thank you.